Hey, we have here a homemade integral. That means one that I did myself. And what we're doing is we're integrating from minus pi over 4 to pi over 4 sine squared x plus 1/2 over 1 plus e to the sine x dx. Okay, let's get right into it. What I'm going to do to start is we're going to do a u substitution. I'm going to do, this is pretty good a lot of times when you have like symmetric bounds. So we'll do u equals minus x, and then therefore x is going to be minus u, dx is minus du. And then we'll make this substitution. It's just going to change the bounds. Basically, it's just going to change the sign of the bounds. So we're going to be going from, now we're going from pi over 4 to minus pi over 4. Now when I plug minus u into sine squared, the thing is, because we're squaring it, see if we plug the minus u and then we could bring the minus out front, but then we square it and the minus goes away. So I don't even need this minus here. So I'm just going to write this as sine squared u plus 1/2. Then we'll have 1 plus e. Now again, okay, so we're sine minus u, but again, sine's an odd function, so I'm going to do is take this minus up front here. And then we're going to have our minus du. Well, now I'm going to take this minus out front of the integral, but I'm doing that just in order to swap the bounds. So what I can do is change this back to like what we had here. Now we're going from minus pi over 4 to pi over 4 again. What I'm really aiming for is adding these two together. That's kind of the trick of these. So what I want to do is I want to do a variable change and get this back to x, because in a definite integral I can do that because we're just looking at the area under the curve. Variable name doesn't matter, but it's going to help me set up the it's going to help me in the future. So let's just change the variable. Okay, now from here, now what I'm aiming for is to add this to the original integral. And what I want is, so we have the same variable, we have the same bounds now, but I want the denominators to be the same. We've got this minus sign to deal with. Well, what I can do is, let's just multiply numerator and denominator by e to the sine x. I think this is going to work nice. So let's multiply this in here. So first, let me rewrite my numerator. I'm just basically copying everything over, but let's show that we're multiplying now by e to the sine x. Now in the denominator, let's do this carefully. E sine x times e minus sine x. We add the exponents and we get e to the 0. Well, that's just 1. And then 1 times e to the sine x is e to the sine x. And now we have the same denominators here. So what I'm going to do is, let's call our original integral I. All this stuff's I, so this stuff is I too. And what I'm going to do is I'm going to add this one to this one. We'll have two copies of integral, we'll have 2i. And because we have the same bounds, same variable, same denominator, it's going to come together nice. Now up top here, you see that I just basically copied down. This is our original integral, and this is what we came to for our second copy. And we just added these together as two separate integrals. But with the same bound, same variable, I can combine this into one integral. We have the same denominator, so we just added the numerators here. And then from here, what I notice is we have this term in common, right? Sine squared x plus 1/2 in each of these. So what I can do is, if these two terms are in common, we'll factor it out and we can rewrite this. I can just, after factoring, I can just write this as 1 plus e sine x. But the beauty of that is this is going to just cancel with this, and now we're integrating sine squared x plus 1/2, and that's something I think we know how to do. Now I'm going to take my sine squared x, I'm going to rewrite this using this power reduction formula as 1/2 minus 1/2 cosine 2x. But then let's not forget this 1/2. Because we have 1/2 plus 1/2, I'm going to just rewrite that here as 1. One thing I can do before I integrate, cosine's an even function. Okay, so this whole thing is going to be an even function. So what I can do is, and we have symmetric bounds, so I can change my lower bound to 0 and just bring a 2 out front. But what that's going to allow is I can cancel this 2 with 2, so now this integral is just the same thing as our whole solution, so it's going to simplify just a little bit. So let's integrate this thing. Integrating 1, we're going to have x. Then integrating cosine 2x is going to be sine 2x, but we need to bring a half out of this times this half here is going to be a fourth. And we're just evaluating this from 0 to pi over 4. When we plug 0 in, this is going to be 0, but sine of 0 is also 0. So we're just going to worry about pi over 4. Let's plug our pi over 4 in. So pi over 4 and for x is pi over 4 minus 1/4. 2 times pi over 4 is pi over 2. Sine of pi over 2 is just 1. And this is about it, but we have a common denominator, so I'm just going to write this as pi minus 1 over 4. And that's it, we're done. So that's it. We'll stop it there. Thanks everyone for watching. Have a great day.